All right, here we go. Here's another basically Algebra 1 review section. So we're not going to do a whole lot of problems in this first part. 11.7b will be Algebra 2 trig review, not Algebra 1. So we're going to graph a system of inequalities. They're both lines, right? So we want to solve for x. That's not what I meant to say. We want to solve for y in both of these equations. So I want you guys to take a minute and solve both of these equations for y. Go ahead and pause me and solve for y. I'm not going to show the work for these, so make sure you're actually solving, please. Okay, so on this one, we're going to get... Actually, I'm going to color code these. I'm going to do these in different colors. Now, hopefully you know why it switched from a greater than or equal to a less than or equal to, right? Because at some point we divided by a negative, so we had to flip it. And here we're going to have that. Okay, and then we're going to graph. I mean, it would be nice if you guys have graph paper to do these. It's not that big of a deal if you don't. I actually didn't bring any of my graph paper home, so my graph isn't going to be beautiful, but that's okay. So we're literally doing an Algebra 1 problem here. We're going to go, excuse me, m is 3 over 1, b is negative 6. We all remember that b is on the y-axis. I'm going to go way down because I want to have a nice graph, especially since I don't have graph paper. So 1, 2, 3, 4, 5, 6. Did I count that right? 1, 2, 3, 4, 5, 6. Yes. So the y-intercept is negative 6, and the slope is positive 3. So up 1, 2, 3 over 1, or down and left. I'm not going to connect those dots yet because I want to see where the two equations or the two lines intersect. So the orange one has a y-intercept of 1 and a slope of negative 1/2. So we're going to start at 1. We're going to go down 1 and right 2, or up 1 and left 2. Okay, so those would be my two lines. They both are solid because they both have the equal bar. Remember, if it doesn't have the equal bar, it's a dotted line. And I want to know where these intersect so I can see if I kept going up 3 and right 1, I would end up right there as well for that line. So that is the point of intersection at 2, 0. And this one, y is less than. So we're going to test that one out. The orange one is going to be more obvious. Maybe the green one is obvious to you, but just in case it's not, we're going to test it out. Y is less than, well, that's clearly below. Okay. If you like to shade, like do some light shading below the orange line and then do some light shading on whatever side of the green line, you can do that. I like to draw arrows because I just like to keep it a little bit neat. So the way that I'm going to test this, because it seems like this would be less than because it's kind of below, but then this is to the left. So which one is the less than? You might already know this, but I just want to be safe, just to make sure that everybody's good with this. I always just pick a test point. I always pick 0, 0 as my test point because it's the easiest thing to plug in. If I test out 0, 0 by plugging it in here, I would have 0 less than or equal to 3 times 0 minus 6, right? And then that would give me what? 0 less than or equal to negative 6, right? Is this a true statement? 0 less than or equal to negative 6. That's false. So that means the shading does not go through that. It doesn't go this way. The shading goes the other direction, away from that test point. If this were true, the shading would go towards the test point, okay? Now, here's a good way of thinking of it. This is saying y is less than or equal to. Less than or equal to in the y direction is going to be below, not slightly above. So don't get confused with like, oh, but that's to the left and that's less than on the x-axis. We're saying y is less than, not x is less than. And then we want to just figure out where are the green and the orange arrows pointing towards each other. That's this whole section in here. So what this means is that any point in this shaded region, including the points along the solid lines, will work if I plug it into both of the equations. So let me show you that. I see like 2, let's go 2 negative, what is that? 1, 2, 3, 4. 2 negative 4 is a point that's in that region. And if I plug it in, I'm going to plug it in here. 3 times 2 plus 4, right? Minus negative. Greater than or equal to 6. I can already say that that's true. I don't even need to do any math beyond that. And then plugging in 2 negative 4 here, I have 2 negative 4. And I can already see that's true as well because that's going to be negative 8 plus 2 on that side. Okay, that's a 6, not a B. That's a 6, not a B. These are more obviously 6s, right? So any point in this shaded region is something